Maintaining high availability. All right, high availability. What we're covering in this video is, of course, keeping our servers and our databases, which will, of course, keep our data, highly available to our users. So, of course, servers are going to crash. That's just the nature of the business we're in. What can we do to circumvent that crash and get another server up and running as fast as possible? Same with the database. If a database becomes corrupted, what can we do to get another database up and running as fast as possible? And that's what we're going to be covering in this video is, of course, maximizing our uptime by minimizing our downtime. So we'll take a look at all the different technologies available to SQL Server in the high availability arena that'll help us solve these issues. So first section here, Introduction to High Availability, we'll analyze first a hardware solution. We'll briefly touch on failover clustering and see how that fits into SQL Server 2005. We'll also take a look at two software solutions, log shipping and database mirroring. Database mirroring, brand new to SQL Server 2005. So we'll take a big look at all these technologies here, take a look at how they all work, and of course what situation will be suited best for each technology. We'll then move into log shipping. We'll take a big look at log shipping, how to use log shipping, how to monitor log shipping, and then we'll move in and take a big look at database mirroring, how we use it, and of course how we monitor it. All right, so let's get cracking here. The first thing we're going to do is get familiar with all of these technologies by taking a high-level overview look at each one of them. The first one we're going to look at here is failover clustering, and failover clustering is the most complex solution of all of them, but it also offers the most protection. And really, it's high availability for an entire SQL Server instance, not just a database where these other two technologies are, but an entire instance. And it is a hardware solution, and because of all this, of course, it's going to be the most complex and the most expensive solution out of the bunch, so it may not be a practical solution for most of us out there, small businesses and such, but for large businesses or businesses that have super secure data or super sensitive data or mission critical applications, it may be our only option. So how this works is through a little technology called MSCS, Microsoft Clustering Services. And Microsoft Clustering Services comes with, if you're using Windows 2000, you're going to need Windows 2000 Advanced Server or above. And if you're using Windows 2003, you're going to need Enterprise Server or above. So you're going to need a pretty robust operating system if you're going to even think about doing failover clustering, because that's what Microsoft Clustering Services comes with. Now, how this works is you're going to need two or more nodes, and a node, of course, being a server, to accomplish this. And you're also going to need two or more shared disks to accomplish this. So in our scenario here, we have three nodes, three servers. A, B, and C is their respective computer names. And how this would work, of course, each one of these servers would still have local storage. So you'd have your local storage set up here. And each of these servers could still act independently for other applications. But if we're going to use a cluster, we would actually set up SQL Server. We would install the SQL Server binaries locally on each one of these servers. And they can have different names. It's just a matter of they need to be configured pretty much the exact same way if this is going to work. So we get SQL Server set up on each one of these machines. Then we also get our database. Whichever databases we want to participate in this cluster, we would need our databases on our shared disks here. So of course we could still have local databases here, but of course they wouldn't be able to participate in any sort of a clustered resource group. And that would be what would happen next here is we would need to create what's called a resource group. So how we would do this is by, again, running a SQL Server setup, only this time we'd run a special setup. You've probably noticed it if you've run SQL Server installation before. You'll see when you get to the point where you have to specify what type of installation you're doing, if you're just going to do a standard install by specifying an instance name, or you can specify a remote install, or you can also specify a virtual server. That's what you would choose. You would choose the virtual server install, and that will only be enabled if you're running on a PC that has Microsoft Clustering Services on it. But basically what you would do there is you would set up a resource group, and that resource group would define things such as an IP address to hit this specific cluster. You would specify, more importantly, a name. So we could call this SQL Nugget or SQL Cluster, whatever the name of our that we would want outside users to connect to our cluster via, named pipes or whatever to access our SQL Server data. This is what they would use, this one single name. So to the outside world, this cluster is accessed by this one name. Inside, though, of course, we have three computers working. And how this would work here, let's say we would have what's called a primary server, or a host, that would be pretty much serving all the requests for this data. So on this host, say something goes wrong, our network connection goes down, or even the server crashes, what would happen is it would automatically fail over to one of our other servers in our resource group, so one of these other nodes here, and they would immediately begin picking up all the process tasks. And that downtime is so minimal, it's like 2 to 5 seconds, I think, is really the downtime. So that's the nice thing, and the entire server fails over. So of course the local stuff would be down if you have any local things installed, but anything that was in the cluster would automatically be transferred over to our next node, and boom, it would pick up the processing task. As soon as you get this one back up online, everything would sync up and it would be back up online. So that's failover clustering in a nutshell. And again, the complex part here is just because we have so many components involved, it's really just setting up all of these components, getting the right operating system, getting Microsoft clustering services on there configured, configuring all these instances to be the same. That's the complex part, and really just time consuming, not really complex. Setting up clustering services and setting up your actual resource group itself is a piece of cake. Now, moving on over to database mirroring. Database mirroring is brand new to SQL Server 2005, and it's a very, very, very cost-effective, easy to use, easy to implement way to give high availability at the database level. So, database level is what we're talking about. It's a software solution because we're going to configure it inside a SQL Server. But database mirroring is very, very cool. I'm totally digging it. I'm having a lot of fun using it, and I think you will too, just because of the ease of use. It is so easy to use and so easy to set up that I can't see why we wouldn't use it as a high availability solution. And it's cheap because it comes with SQL Server. So how database mirroring works here is let's say we have a production server out there, we have a production database that we want to mirror. We want an exact replica of this database out here on another server somewhere, just in case something goes wrong, it becomes corrupt. We'll have a hot standby, known as a hot standby here, so we can just immediately toss this database up online and our users can start using it. So the reason this is called a hot standby because it is a near real-time synchronized copy of our principal database. And a principal is just a fancy word for the database that's getting mirrored, so our primary database here. So what we would do is we would use SQL Server configuration here. We would configure this database as the principal database, and then we would pretty much specify what server we would want to hold the mirrored database. So we could say, yep, we want this server over here to hold the mirrored copy, and these would be considered partners in a mirrored database. Now, I'm not even talking about a witness yet, so kind of keep this out of here for now. In its simplest form, this is how database mirroring works. As soon as transactions get entered into our principal database, they automatically get applied over at the mirror in near real time. So we have a constant flow here going from principal to mirror, and again, it's a near real-time synchronized copy of our principal. Now, if anything goes down in this scenario, if our principal goes down, for instance, we would have to go into our mirror and do what's called manual failover. We would just basically turn our mirror into the principal and then redirect all of our client applications to use our mirror. Now, if we use a witness, on the other hand, our witness server kind of just it really just monitors our principal and our witness. This will be called a quorum, and we'll get into this, the technical know-how of this here when we get deep into database mirroring. But basically what a witness allows us to do is automatic failover. Just like our failover clustering did over here, as soon as this server goes down, it automatically fails over to this node. Same thing here. If a witness is involved, it can monitor both the principal and the mirror. And if something goes wrong here, if our principal goes down, for instance, then this witness will say, hey, mirror, do you see the principal? The mirror will say, nope, don't see it. Okay, then we'll go ahead and make you the principal, and it'll do automatic failover. This will automatically become the principal, and again, your users won't even notice. You can automatically redirect all of your client applications to use this principal, and I'll show you how to do that as well. Pretty cool thing there, that you can automatically redirect applications to use this, and again, seamless. The users wouldn't even know this. But that's the basic gist of database mirroring. We're going to cover all these scenarios and talk about all the different forms of database mirroring when we get there. The final high availability solution we're going to look at here is log shipping. And log shipping has actually been around since SQL Server 7.0, so nothing new here. It's another high availability solution at the database level, and it's also a software solution. So it's very similar to database mirroring. The difference here is we're talking about a warm standby, not a hot standby, and what that basically means is that our secondary databases are not really in real-time sync with our primaries. And you can see the terminology here is a little bit different. We have primary instead of principal, and we have secondaries instead of mirrors. So just the old terminology, since it's been around, they stuck with it. But again, basically what happens here is our secondary databases are always trying to catch up to our primary databases. They're never quite synced up exactly the same, nor will they ever be synced up exactly the same. That's just the way it is. And the reason that is because our primary database doesn't send over transactions as they happen to our secondary transactions. What happened is when we set up log shipping, it's all controlled through SQL Server agent jobs. And what happens is basically the primary server has a backup job that backs up the transaction log at specified intervals to a network share somewhere. So this network share would hold all the transaction logs. Our secondary databases would then have SQL Server jobs as well set up on them that would come and get these transaction logs, bring them back to the server, and apply them to their databases. So that's why they'll never really completely be in sync, just because we have jobs doing all this running at different intervals. So of course we can specify the latency on those jobs, but no matter how low the latency you set on them, they're always going to be trying to catch up. So log shipping, that's why it's meant as a warm standby, not a hot standby. So with that said, though, log shipping definitely has its place in the world because it can do some things that database mirroring can't. For instance, you notice here we have a couple of servers here for my primary. You can have as many servers as you want getting these logs shipped to them. So your primary server can ship logs pretty much to anything out there, to any number of databases out there. And that's a nice thing. With database mirroring, it's always a one-to-one relationship between your principal and your mirror. That's it. Also with log shipping, users can read from these secondary databases. So you can offload all of your query processing to these secondary databases, such as custom reporting applications or anything that can read data. Of course, you can't write to these secondary databases, but you certainly can read from them. Database mirroring, this mirror is unavailable. It sits in what's called recovery mode, so you can never touch it. You can't even connect to it. So those are some of the benefits of log shipping over database mirroring, and vice versa. Also, you can introduce a monitor server. Just like the witness server, it is optional. The monitor server is nice because what it can do is it can monitor and pretty much record histories from all of these SQL Server agent jobs across the way. If you don't have a monitor server, those jobs will still be set up, but they'll be set up on each specific server, the primary, the secondary, so on and so forth. But if you have a monitor server, you just have one centralized place that does all the monitoring of all your jobs, tracks all the histories, when the backups were occurred, when the transaction logs were applied at your secondaries, so on and so forth. All right, so those are all of our technologies, our highly available technologies in a nutshell. Let's take a little deeper look at both database mirroring and log shipping here and get familiar with the internals of these before we move on in and take a look at how these work with a demo. So we're going to start off with log shipping here, and then we're going to move into database mirroring. So a little bit deeper into log shipping, how this works. Log shipping, as I said, automatically takes our transaction log backups from our primary servers, pops them into a directory somewhere, and then our secondary servers come and get that log, copy it over to their servers, a local drive or a directory over here somewhere, and then it copies them into our secondary database. So the thing is, though, if you're going to do this, it requires the full or bulk log recovery mode, and it only supports manual failover. We can never do automatic failover with log shipping, as I mentioned earlier. And the components of this, as I mentioned, it runs on SQL Server jobs, these actual SQL Server jobs. We have a backup jobs that sits on the primary that does this, as I mentioned, throws everything in here. We have a copy job that sits on each one of the secondary servers that comes over, grabs this transaction log, copies it locally inside of a local directory here. And then we have a restore job also on the secondary server that is going to take those transaction logs on our local server and apply them. And we set all of this up and all the times that each one of these occurs when we configure transaction log shipping. And then we also have our alert job, which, of course, if you have a monitor server, it's going to sit on your monitor server and monitor all of your secondary and your primary servers. If you do not have a monitor server, this alert job will sit independently on each one of these servers. So you'd have to look at each one of these servers' logs if you want to see any histories of when these agents ran and what their statuses were. Now, a brief note on manual failover here. If our primary server goes down, what do we do? Well, it's highly unlikely that we're synchronized between our secondary servers. So let's say we want to bring one of our secondary servers online to take over the processing, and basically we want to do a role switch here to make one of our secondary servers our primary server. Well, what we would do, the first thing we would do is take any of these remaining transaction logs that have yet to be copied over to our secondary server, and we want to copy them over into that destination folder and apply them sequentially into our secondary server. The next thing we would do is we would want to get the active transaction log. So these are the transactions that are sitting in the transaction log on our primary server, because let's say our backup job ran 15 minutes ago, and this just happened, so we have transactions that are out there that have yet to be backed up. So we would take a backup of that, which is of course called the active transaction log. We would back that log up and also copy it over here, and then we would apply that log to our secondary server, only we would specify with recovery, which would of course bring the secondary server online. The next thing we would do is over on our primary server, we would disable this backup job over here. And then on our secondary server, we would disable the copy and the restore job, and we would just basically flip them around. And so we would enable the backup job here in our secondary server, and that's it. That would make this the primary server. It'd be up and running. And then what would happen is once we got our primary server back online, we would just do the reverse. We would back up all the transaction logs that have taken place since this crashed, back over here, re-enable the backup job over here, disable the copy jobs, and then do the exact opposite over here. So a little bit of work with manual failover, but it's not that bad. The process is actually pretty simple to do. So that's log shipping. Again, log shipping, very simple to use, simple to set up, simple to maintain and manage. The only part that is a little time consuming is, of course, this manual failover stuff. But even that, it's pretty simple to do. Once you get the process down, it's very, very simple to do. One other thing I want to mention here, a good solid use for log shipping that you'll see out there is offloading query processing from your primary server. Say you have a very, very active production database, a lot of transactions going into it, a lot of users connected to it, and you want to improve performance a little bit on here. One thing to do would be to point all your read-only applications, because again, you have read-only access to this data, point those applications over to your secondary servers. If they don't mind the latency of the data, in other words, since it's not a real-time look at the data, if that's okay, then it wouldn't hurt to point some of these users and their applications over to these secondary servers to get some load balancing going on between your primary and your secondary servers. So, log shipping, that's how it works. We're going to get into a demo here shortly and take a look how it actually works in SQL Server and how we can use it. But before that, we got to take a look here at database mirroring. So database mirroring is something we should all be excited about. It's a very, very nice, very easy to use, very viable software solutions for keeping our databases highly available. And you'll agree with me here as soon as you see it in action. Very cool stuff. Now, database mirroring is going to require the full recovery model in order for it to work. So you're going to need that going. Again, how this works is, depending on our operating mode, this operating mode is really going to define how our transactions are sent over and applied at the mirror. Because as I said earlier, basically how this works is again, as soon as a transaction is entered into our principal, it automatically gets tossed over to our mirror and applied there. Now, actually, let me mention something before we go any further here. Database mirroring is unsupported in the initial release of SQL Server 2005. However, just a few weeks ago, Microsoft released SQL Server Service Pack 1. Service Pack 1 is supported. If you have Service Pack 1 installed in your SQL Server 2005, database mirroring is fully supported. So go out and get SP1 if you're going to use database mirroring. If you're not going to get SP1 and you want to use database mirroring, you can turn it on. It's actually turned off by default. You can turn it on by running a dbcc command, a database consistency checker command here, and pass in, you need to do the trace on and pass in 1400, the 1400 flag. Running this will enable database mirroring on anything that is in SP1, anything before SP1, so basically the initial release. So I just want to mention that. Get SP1 because it'll be enabled by default. You don't have to worry about this trace stuff, and it's supported, so big thing there. Now, back to where we were talking about here, our principal and our mirror. Again, principal, transactions get entered at the principal, automatically tossed over to our mirror and applied there. Again, optionally, we can have a witness server, but if you want to do automatic fail over here, you're going to need to have a witness server. It's the only way we can do automatic failover is to have this witness server. And basically how this works is by something called a quorum. So a quorum is just simply means that we have servers currently in communication. So that's a quorum. And we can have three types of quorums. We can have a full quorum. A full quorum means all three of these, the principal, the mirror, and the witness, are all currently in communication with each other. They can all see each other. They can all talk to each other. That's a full quorum. We also have what's called just a quorum. A quorum would be pretty much something between the witness and either partner. So one of these guys is offline, the principal or the mirror. So that's just a quorum. We also have a partner-to-partner quorum, and that would be where just our principal and our mirror are talking to each other, so the witness has gone offline. So full quorum here, just a standard quorum between a witness and one of the partners, and then a partner-to-partner quorum between our principal and our mirror. And this is going to matter because, again, this is going to determine when and how automatic failover happens, if it happens, because basically what happens here is if we have a full quorum, fine, everything's peachy, everyone's communicating with each other, all the roles will stay the same here between our principal and our mirror, unless you do manual failover. That's the only way a role will occur, and you may do that just because you want to, for whatever reasons. Now let's say that we have a standard quorum here and one of our partners went down. Let's say first that the mirror went down. So our mirror went down, our witness and our principal retain quorum. What happens? Well, what would happen here is the principal would know that the mirror is down, and it would actually put the mirror itself in a suspended state. So we wouldn't be mirroring anything over there, and this would be bad, of course, but the odds of our principal going down as well are pretty slim. Two servers going down at the same time, as long as they're on separate physical servers, are pretty rare. Unless, of course, the internet or the network goes down, which, of course, we'd have bigger problems at that point. But basically what would happen is as soon as this mirror came back online, the principal and the witness would know that, and the mirror would begin resyncing with the principal. As soon as it was done resyncing, boom, the mirror's back up. Pretty nice. Now, if the principal, on the other hand, goes down, the witness and the mirror are in quorum. What would happen here, and this would happen in about, I think about 2 to 8 seconds is about how long this would take to happen. The witness would say, okay, the principal's gone. The mirror would say, okay, the principal's gone. Guess what? We need to do automatic failover here as soon as possible. So that's exactly what would happen. The mirror would automatically switch roles to become the principal and then start serving the connections from anything that used this data. And what would happen then is once the principal came back online, it would know that the mirror is now the principal database, and it would automatically begin resyncing to the mirror, and now it would turn itself into the mirror. So now you'd have a role reversal here. This would be the principal, this would be the mirror, and that's the way it would work until either you did something about it or you could leave it like that and switch it back again manually. But the point is, automatic failover then would still occur. It would just occur in the opposite direction. And now finally here, let's say we have partner-to-partner quorum going on, and say our witness went offline. Well, if our witness went offline, what would happen is automatic failover would be no longer possible, but our mirror would still be functioning fine. And as soon as our witness came back online, it would rejoin the quorum, and we'd have full quorum again, and high availability through automatic failover would again be possible. So that's how automatic failover works, and we're going to take a look at just how all of that works. I actually built a little custom application in VB.net, and we're going to pretend we're a user running that custom application. We're going to take our principal server down, and we're going to watch automatic failover happen just as if we were a standard user. So pretty cool stuff here. Show you how that works. So that's how quorum and automatic failover works. Operating modes, this is again how this data gets thrown over the mirror, and this is important because we have 3 modes: high availability, high protection, and high performance. High availability is what we were just talking about here. It requires a witness. It's the only way you're going to be able to do automatic failover. It's a synchronous operation, and that's what makes it safe. And what it means by synchronous here is basically what happens is once transactions are tossed into this principal database, before they're committed at the principal, they're sent over and committed at the mirror. Once they're committed at the mirror says, okay, I'm done. Back over it at the principal says, okay, you got it, great, I'm going to go ahead and commit that transaction. So that's why it's high availability, and that's why failover is possible, is because we always have the same data over here. We're never out of sync. And that's the only way we could do automatic failover, is if we were never out of sync. Now, high protection mode is pretty much the exact same thing as high availability mode without a witness. No witness here. And it's the same thing. It's a synchronous operation. Transactions are committed at the mirror before they're committed locally at the principal. And this, again, just guarantees consistency between our databases, because things have to happen over here before they happen over here. And since they're coming in over here, we're always going to be in a consistent state between the two. High performance, on the other hand, is a little bit dangerous in the fact that we could suffer from some data loss. We could lose some transactions here because this is an asynchronous operation. Again, this has no witness to it, but an asynchronous operation, which basically means that as soon as transactions come into the principal, they're committed and then they're sent over to the mirror. So we're not guaranteed transactional consistency here. And if something goes wrong at the principal before they were sent over to the mirror, then we're going to lose those transactions. Simply because we have to do what's called force service. If we need to bring our mirror up to become the principal, we'd have to force this service, and then boom, all of a sudden this becomes the principal, and anything that happens over here then will nullify this transaction log over here that has maybe outstanding transactions in it that have yet to be committed, or that have been committed but haven't been sent over to the mirror, because now your mirror becomes the main database, and when it gets resynced up with the principal, oops, it just overwrites anything that happened over here that wasn't sent over here. So it's dangerous in that sense. But if there is a little performance hit on both of these, because it does have to travel over the network to commit it first before it comes over here. So this may be a viable option if you have a lot of activity and you still want to use database mirroring, but you cannot take that kind of performance hit by using high availability or high protection. So it does have its place in the world. Another thing I want to mention here is this synchronous versus asynchronous. All this is a switch underneath the hood called transaction safety. So transaction safety set to on is a synchronous operation because on means that you have transaction safety. You're guaranteed transactional consistency between your principal and your mirror. It's set to off. It's an asynchronous mode. It's committed here first, and then you don't care. You just send it over to the mirror. You don't care what happens over there if it gets it or not, but it's sent over. All right, now that we know pretty much everything there is to know about database mirroring and log shipping, let's head on over to SQL Server 2005 and learn how to implement this stuff. So let's hit on the Start button down here, click on it, head on over to Programs, and on over to SQL Server 2005, and right down to our Management Studio here. So as this fires up, let's go ahead and cancel our connection, our ad hoc connection to a server here. Let's drop down our production server and connect via Object Explorer to our SQL Nugget, SQL 2005 production machine. And then let's head on over to how about a test machine here. Let's pop into VB Nugget, SQL 2005 test, and let's talk about log shipping. How do we do log shipping here? And we're going to do it from our production database. Here we have an AdventureWorks database down to our, we're going to, using log shipping, automatically create that database here in our test machine and ship our logs to it. You can see there's no AdventureWorks database down here, just the data warehousing one, not the standard one that we're going to work with here. But to use log shipping and configure it, very simple. We right-click on our AdventureWorks database, the database we want to do here. We can go to Tasks, and then Ship Transaction Logs. You can also go to Properties here, and if we go to Properties, you can see, if I maximize this here, Transaction Log Shipping. If you go to that Transaction Log Shipping menu, it'll just take you right here. Once you're in here, we're going to say we want to enable this as the primary database in our log shipping configuration. As soon as we do this, the first thing we need to do is set up our backup job, as I mentioned earlier here. So backup settings, what we do is configure our backup job by first configuring what network path is are these backups going to be, our transaction log backups, going to be sent to. So we need to specify our network folder so our secondary service can come and get this data. So of course I have a network share out there that they can access called SQL Nugget Backups. Also, if this folder up here is located on the primary server, you can type it in here, so SQL Server can just, our SQL Server can just dump these transaction logs into here. Just so happens that it is. So there we go, our local machine. The next thing you can do is you can have it automatically delete files older than this amount of time to, of course, save on storage, a good idea to do. And you can also send an alert, create an alert. SQL Server will alert you. You can set up this specific job here to alert you via email or NetSend or whatever. During this specific hour or during this specific threshold, if that were to occur. Also, our backup job here, you can give it your own name, otherwise you can leave it at the default name here, but this is the backup job on the primary server that's going to be backing up these transaction logs. And you can also set the schedule here. By default, every 15 minutes. Let's trim this down, let's say every 5 minutes, create a backup of that transaction log, and copy it into our backup folder so our secondary service can come and get it. And that's it. This is all you have to do to set up the primary. Pretty simple. The next thing we need to do is set up our secondary servers and our secondary databases. And to do that, we just click on the Add button here. First thing we need to do is specify what instance are we going to be shipping these transaction logs off to. So we click Connect here. We'll choose our VB Nugget SQL 2005 test instance. The next thing you do, what database on this instance are we going to copy it to? Now, since it doesn't exist, it's going to automatically default to the name of our primary database instance, so we'll leave that there. The first thing we need to do is initialize it. We need to basically create a synced up version. We need to have an exact replica of the database that we are getting shipped from, our primary database. So we have a couple of options here. We can either generate a full backup right now of the primary database and restore it to the secondary database and create it if it doesn't exist. This is the option we're going to use because it doesn't exist and we don't have any backups lying around. The restore options here is just basically where do you want these files to be put and restored from on the actual secondary server. So our VB Nugget SQL 2005 instance here. If you leave it empty, it'll use the default path that SQL Server uses. So we'll leave that empty. Also, you can say, yes, I have an existing backup lying around. I don't need you to create a new one in case you have a very large database. Then you can just specify the backup file. Same exact restore options here. So that's that. Or you can just say, nope, it's already initialized. We're already synced up. We did all this manually ourselves. We're ready to go. But we didn't, so we're going to choose the first one here. The next thing we need to do is set up the copy job on our secondary server. That's exactly what this is the copy, SQL Server Agent copy job. We need to specify a destination folder because remember, this job is going to run over and grab those files out of the backup directory that we just specified in our backup job over on the primary server. So I actually have one of those set up as well. And I have them locally on our VB Nugget sql2005 test machine as sql restores. So here's that destination or that restore folder where it's going to copy those transaction logs into from our primary server. And we can say the same thing. Do we want these deleted after so-and-so hours? And we're going to say, yep, we want them deleted after 72 hours. We can click on schedule here. And again, this is just same thing, just setting up the schedule of the job. So we'll say, yep, we want this to run every 5 minutes as well. So we'll choose 5 here and click OK. Our final task here is setting up our restore job. So the restore job is the one that takes these transaction files out of our destination folder here locally and applies them to our secondary server. Now there's a few things you can do here. Once you do this, you can choose to leave the database state in no recovery mode, which you're basically saying you do not want anybody ever to be able to connect to this database. It's kind of like database mirroring in that sense. No one will be able to connect to the secondary database. If you do standby mode, however, people will be able to have read-only access to this database. So this is nice. This is where if you want to do offload query processing, you're going to need to do this. And if you want, you have reporting applications that can access this database to offload that processing from your primary server, good idea to do this. Also, you can disconnect users in the database when restoring backups. You may want to do this. If you do not do this, then transaction log backups cannot be restored. Transaction log backups can only be restored when there are no connections. But what will happen is it's not that they'll never get restored, they'll just pile up. And then when there are no users finally connected to the database, then it'll restore all of those logs sequentially. So you may or may not want to do this. We'll leave that unchecked. You can also delay restoring backups at least this number of minutes, or you can, of course, send an alert if no restore occurs within this amount of time. Maybe if it goes too long, you may want to automatically disconnect your users so this process can happen. And then again, we can set up a schedule for this job as well. So we'll click on a schedule here. Let's also make this guy 5 minutes to reduce the latency time here between our synchronized primary and server databases, or secondary. And we're all set. So we click OK, check it out. We're all set now. We have our primary database enabled. We have one of our secondary server instances enabled. You can enable, again, as many as you want in here. We'll just leave it as one for now. The final thing we can do here is specify a monitor server. So we'll just put a tick here to enable our monitor server instance. Next thing we do is specify our monitor server instance. We'll click connect here. We'll choose VB Nugget. That'll be our monitor instance here, our monitor server. The next thing we need to do is just specify the security context for what this agent, this specific job, is going to use to connect to all of these other jobs to gather their history and gather their statuses. So we'll just say go ahead and impersonate that account since that's a domain admin account anyway. The next thing we do is use history retention here. You can delete history after a certain number of hours. And then, of course, same thing here is the job name. You don't specify a schedule because, of course, it continuously runs. So we'll choose OK here. Boom. Now we have a monitor server. Log shipping is set up. Once we click OK, it's going to go ahead and set all of this stuff up, back up our database, restore the database. So we're pretty much syncing it on the secondary server, save the destination configuration, create all of our jobs, set up our save our backup information, and then set our monitor configuration information. So I'm going to go ahead and pause this because this is going to take a little bit to do. Be right back. And there we go. Bada bing, bada boom. We are all set up. I'll click close here. Now, if you go down to our secondary server and we expand our databases, check it out. We now have an AdventureWorks database. It's a standby. It's read-only. So our users can still access this database. We can point all of our reporting applications here to offload some of that activity from our primary database. Another thing I want to show you here, how you can monitor log shipping. If you right-click on your primary instance, or just click on your primary instance and come on over here to reports and go down to your bottom report here. Look at this, transaction log shipping status. This is a nice report. It's just very easy to read, shows our primary database, our secondary database, shows the backup information, the copy information, restore information, just basically all of our jobs. So everything that monitor server is, all that data it's compiling goes into a nice, well-formatted report here. Also, if you get onto your VB Nugget, if you go down to your secondary database, drop your reports down, you get the same thing on the bottom here. It'll give us a little more information at the bottom regarding our restore job, since that's where it sits. So that's transaction log shipping. Simple to configure, simple to use. we're all set and ready to rock with transaction log shipping. Everything that goes in, again, to our AdventureWorks primary here. Again, when those jobs occur, they get backed up over on our primary server. Our secondary instance grabs those whenever their jobs gets kicked off, grabs them, brings them over to the destination folder. The destination folder then has that transaction log for the restore job to kick off, grab that log, and apply it over on our secondary server. So that's transaction log shipping and how it works. Let's move on over to database mirroring. And how this is going to work for database mirroring, we are going to take this database over here in our SQL 2005 prod instance. We're going to have an AdventureWorks prod. So say we have a production database that we want to mirror over here. What I'm going to do is I'm actually going to disconnect from our VB Nugget machine here. And I am going to connect to our SQL Nugget SQL 2005 dev box. And now I just want to put a little disclaimer out here. This is not a very smart thing to do with database mirroring. You can see these are both on the same server, just different instances. If the server went down, database mirroring is pretty much pointless. So just for demonstration purposes, to make things go faster, so when we click those OK buttons to configure things, everything will go a little bit faster. So that's why I'm doing this. So demonstration purposes only. Ideally, though, you'd want to have another machine host the actual mirror. So the first thing we need to do here, you'll notice this, our SQL Nugget SQL 2005 dev instance here does not have an AdventureWorks prod database. The first thing we need to do is get this database over here synced up to the state that this is in, same exact state. And also we need a database to be in no recovery mode, because remember, we can't have people accessing this database. So it needs to be in no recovery mode. That's the prerequisite to getting mirroring off the ground. So that's what we're going to do to start here. Alright, so rather than dragging you through all that backup and restore process, what I did is I created first a full backup and then a transaction log backup, and that's exactly what you need to do, again, as I said, to get database mirroring off the ground. The next thing you do is you restore the full and leave it in no recovery mode, and then restore the transaction log, also leaving it in no recovery mode. I restored the full. Now let's go ahead and restore the transaction log together here. So we'll go to Tasks, Restore Transaction Log, and we'll go ahead and say from a file here that I created, we'll add it here. This will browse through the file system on our SQL Nugget machine. I'm just going to specify our log backup that I created here, AW log. Choose OK, choose OK. We want to select that. Everything looks good here. On the Options tab, we just want to, again, make sure that this says Restore with no recovery. You really need that there. That's the only way database mirroring is going to work. And then we'll choose OK. So that's going to go ahead and restore that transaction log. Takes a second. And boom. Now we're in a restoring mode. Now we're ready to do database mirroring. So if I right-click on our primary, this is going to be our principal. This is what we want to be the principal here. So I'm going to right-click on there. You can go to Tasks, and you can go to Mirror here. That'll again take us right into the properties. You can also go right-click, choose Properties, and then click on Mirroring here, just like transaction log shipping there. I'll maximize the screen here. And here we go. This is all there is to configuring mirroring. The hard part there was basically just backing up. Actually, not even hard, just the kind of the long part is backing up your database, backing up the transaction log, restoring it, making sure it's in no recovery mode. Now we can come in, we can choose our principal, choose our mirror, and choose our witness, and then choose our operating mode. Now, how database mirroring actually communicates, how all this communication occurs between our principal, our mirror, and our witness is through something called an endpoint. Endpoints are brand new in SQL Server 2005, and it's just a communication point, if you will. Really, what they are web services at the SQL Server level. And if you're not familiar with a web service is something, it's just a programmatic unit, kind of what's called a function or a method that sits on a web server that can accept incoming calls to it. And the nice thing is it's basically like a method or a function, if you're familiar with programming at all, that sits on a web server. So you can call it from anywhere through the web. So it's a function that sits on the web. That's all an endpoint is in SQL Server. It's a communication means in SQL Server that sits in SQL Server. The difference between an endpoint and a web service is that an endpoint does not need Internet Information Services, IIS. Endpoints in SQL Server 2005 actually directly communicate with http.sys, which is the kernel for HTTP. So pretty cool stuff here, and it's very easy to use endpoints. And that's exactly what we're doing here to configure database mirroring, is configuring our endpoints. So if we click on Configure Security here, it's going to walk us through this wizard, very simple wizard. First thing it's going to ask, do you want to include a witness server? And we're going to say yes to this one. We then choose Next. Then it's just going to tell us, of course, we have to configure the principal, we have to configure the mirror. We can optionally configure the witness, but we're going to go ahead and say yes there, and then choose Next. First thing, is, of course, our principal server. It knows what our principal server is since we, of course, right-clicked on it and chose it. The first, and of course, all it's doing here is setting up that endpoint. What port is the endpoint going to listen on? What is the name of the endpoint? We'll call it mirroring. We'll use a listener port. A little note down here, if the principal, mirror, or witness are instances on the same server, the endpoints must use different points, and it'll figure that out for you automatically here. It's just that if you decide to do this manually, and I'll show you how to do that too, then you just have to know that and use different ports there if you're on the same machine. We'll choose next here for our principal. The next, our mirror server instance, of course, we want to go ahead and connect to our SQL Server 2005 dev instance over there. Once you choose it, it's going to ask you to connect to it just to grab the security information. We're going to choose connect, and boom. And you can see it uses a different port because these are on the same machine. So it's going to use 5023 instead of 5022, and then we'll leave it at the same name there and choose next. Finally here, our witness server. What are we going to do for our witness server? We're going to go ahead and choose a remote machine here. How about our web nugget machine for our witness service? So we'll go ahead and choose connect here. Boom, our witness server is set up. Finally here, we need to specify security. Security is important when you're dealing with endpoints. Number one, if your SQL Server service accounts, the actual service accounts are running under different permissions, they need to specify those accounts here. Also, if they are running under local service account, you need to grant permissions to the specific logins for those accounts. So grant logins at the SQL Server levels, you need to do grant connect permissions on endpoint to, and then whatever the user is to grant permissions for that. But I'm using a domain admin account for all this stuff, so I don't have to do any of this. And I'll choose next. Finally here, it just kind of shows us a little summary of everything that's going on. Once we choose finish, creates the endpoints, and we're all set. So we click close here. The next thing it's going to ask us is, do we want to automatically configure this, since it knows what we typed in here, so it knows what mode we pretty much want to use because we have a witness, so it assumes that we want to use automatic failover. I'm just going to go ahead and not start mirroring right now just to show you a few things in here. And here it is. Again, since these endpoints communicate using TCP/IP, this is just what it's showing you here. TCP, the machine, colon, the port that it's communicating on. So you can type these in here manually yourselves. You can see if we remove our witness, check it out. You can't use high safety with automatic failover. But essentially, this is high performance here. Here's our high performance asynchronous mode. Here's our high protection. And of course, if you have that witness set up, I'm going to go ahead and just copy this, change this back to 2.2, and change this back to Web Nugget. Now we can use our high availability mode. So that's what we'll leave it at here. I'm going to go ahead and choose start mirroring. So this will go ahead and fire up our mirror. Make sure all of our communication, all of our endpoints can communicate with each other. And look at that, boom. We are now mirroring. Everything is all set, synchronizing. Data has been transferred from the principal to the mirror. Now if we click OK here, here's how you can tell if you're in a mirroring session. Your mirror database will say principal and that it's synchronized. And then if we scroll down to our SQL Nugget machine, it'll just say in recovery. But if you refresh it, it'll tell us that it is a mirror and it is also synchronized. And it's, of course, in a restoring state. So it just shows us that we're synchronized between our mirror and our primary server there, our principal server. And we're ready to go. So now anything that happens in our production database here, our principal, automatically is flowed to our mirror. Pretty cool stuff. Pretty easy to set up too, huh? Now, one thing I want to do here is show you how we can redirect client applications, or at least show you how you can show your programmers how to redirect client applications to use and take advantage of database mirroring and automatic failover. How this will work here, let me go ahead and minimize SQL Server Management Studio here. I actually created a little application in VB.NET, VB 2005, that we're going to jump into here. If we go to Start, Programs, Microsoft Visual Studio 2005, Visual Studio 2005, this is the .NET 2.0 framework here. I created a little application called demos.mirroring. It's just a mini little database application that will make use of our AdventureWorks database. But basically how this works and how you can tell your programmers that they can take advantage of database mirroring is inside of your app.config file, which stores all of the configuration information for an application. Usually is where they'll put their connection strings, which is how they connect to SQL Server. And here's how it looks like. It's just a data source and then an equal and the name of the actual primary database. So this is what it usually looks like. You have a data source, you choose what database in the data source, and then your security. And we're using integrated security here. Now with .NET 2.0, To take advantage of database mirroring, there's a brand new thing you can put in here called failover partner and specify the failover partner. So what happens if this data source can't be reached, it'll automatically try the failover partner. Pretty slick, and that's it. Just tell your programmers to put this failover partner and then the name of the actual instance in there, and boom. All of a sudden their applications, client applications, will automatically redirect if it can't contact the data source. You can also see this in .NET 2.0 in the My project here. This is just pretty much a wrapper and a little interface around that config file. But here's a setting, connection string, the type, and then the value is in there. So that's how that works. Let me show you how this works, and let's see if this will actually work when we take down our primary server, if that role switching will happen, and if it's transparent or not to our client application. So just a brief little history on this app. What it does, the AdventureWorks database is just a listing of products. What I did is I took that listing of products and loaded it into this combo box so that when you choose a product in here, it'll automatically stream information from the AdventureWorks database, such as the image, streamed right out of the database, a bunch of information about the product, and then all the sales that this product has had. Also down here, it shows what instance we're connected to. I hooked up this status bar here to basically tell us, again, what instance we're currently connected to, the status of our primary server, our primary instance, principal really is what this should say, and the status of our mirror instance. And of course, they're both on right now. So we can sit in here and choose bikes all day long, and you can see we'll get data back, and it's all coming from our prod database. What happens when we go into SQL Server and we stop? We're just going to go ahead and stop our SQL Nugget instance here. We'll choose yes. This will take a second here. I'm going to go ahead and say yes, stop the agent too. This will take a second. I'm just going to pause it. All right, so I'm back, and check it out. Our server is now stopped. Even though this still says principal synchronized, we just have to refresh it when we start off, and this should now be the mirror database when it comes online. If we scroll down here, you'll see now we are the principal down here as our mirror flipped roles. It's now the principal. If we go into our demo, check it out. Didn't even have to do anything since this is on a timer. It automatically knows that we are now connected to our dev database. So automatic failover happened. Our client application was automatically redirected. You can see the primary is offline. Pretty cool stuff, huh? So I'll include this demo here. You can take a look. There's actually not a lot of code to do all this. It's a pretty cool little application. So I'm going to go ahead and stop this guy. There we go. And now if we go ahead and bring back our SQL Nugget machine, if we hit start here, fire this guy back up. I'm just going to pause it for a second while it does it. There we go. And now if we refresh our databases, what will happen is, check it out. Now this guy is in recovery. So total role reversal here. And what will happen is this guy will sync up then with our principal database here. You'll notice that it says in recovery. It doesn't say it's mirrored or syncing or all that because it's currently syncing up with our principal. And then again, automatic failover could still occur once that's all synced up. If this were to go down, then it would role switch again. We could also come in here and we could go into tasks, and if we wanted to make that the primary because we got it back up and running, it's our true production server, then we could come back in here and we could just manually fail it back over to our production instance. So that's how database mirroring works, automatic failover and client redirection. One more thing I want to show you here is how you can actually monitor all of this mirroring stuff. If you right click on any of your mirror databases here, go to tasks and choose launch database mirroring monitor. This is a very simple little application to use here. And you can see all you're going to do when you open this up, if you right click here and choose mirror register database, you simply choose what database you want to connect to. So we'll choose our prod here, hit connect, choose connect, and then it's just going to show you, we already have this one registered, so it's kind of showing me that here. Just shows you the current role. Now before this said the primary role, but now our prod is the mirror role, and it shows the partner what it's connected as, and also the operating system runs on and all that. But you choose OK, it'll register it in here, and just show you the status of everything and what quorum it is in, if it's currently connected with anything. What I did is I actually disconnected our witness from our dev machine just to show you how it would look like here, and it shows it in a disconnected state. So very simple little application, but it also shows you the history here, all the history, pretty much anything. If anything was sent, and all your synchronizations, the data, what it took, lots of good information here regarding it. You can show the last 2 hours, 4. You see a lot of data is tracked here. So a very simple to use, nice little monitoring tool here to use. You can also set up warnings. You can set threshold for these warnings. These specifically inside of here will actually output them to the Windows application event log. But you can do the same thing in Management Studio. You can set up these thresholds as a job to send send alerts or email alerts, whatever you like. But just want to show you where this was, the database mirroring monitor. Very simple little application to use, but very handy because it gives a lot of good data here. And that's pretty much it when it comes to high availability. All right, so in this CBT Nugget, we took a big look at maintaining high availability. We first started off with a look at all the different technologies available to our highly available needs. We took a look at the hardware solution, which is, of course, failover clustering. We then took a look at log shipping. We took a look at how log shipping works, and then we took a look at how to actually configure log shipping. We got it configured. We did a little demo on it, and I showed you there how to monitor it there briefly as well using that report. And then at the end here, we took a big look at database mirroring, how it works, how we set it up, configure it, how we use it, and then we also took a look at a failover scenario. If something were to fail over, how it would work, and also how to redirect our client applications to take advantage of database mirroring. And at the end here, I just briefly showed you how you can monitor database mirroring using the database mirroring monitor. So I hope this has been informative for you, and I thank you for viewing.